Friends, this is Investigation 3, Lesson 7, Water Vapor Math Extension. It is on page 24 of your science water booklets. All right, we are going to take a look at a problem and try to figure out the quickest object to evaporate. So this is kind of a follow-up from our experiment. Some students set up an investigation to find out what effect surface area has on the rate of evaporation. They used 4 different containers: a round cake pan, a water glass, a cottage cheese container, olive jar. They put 100 milliliters of water in each container. Now I want you to kind of visualize here. You got a cake pan. Okay, there's your cake pan. You have a water glass. You have a cottage cheese container. And you have an olive jar. Okay? So kind of look at the shapes of those objects, and that may help guide you and your understanding from the experiment that we just did. Now, the students observed the containers for 6 days. They measured the water on days 2, 4, and 6. The results of their measurements are on the chart below. Okay. For the cake pan, on day 2, it was 75 milliliters. Day 4, it went down to 50 milliliters. Day 6, it went down to 25 milliliters. For the water glass, day 2, it was at 90. Then it went down on day 4 to 80. Then on day 6, it went down to 70. For the cottage cheese container, on day 2, it was at 80. Day 4 to 60, day 6 to 40. And then for the olive jar, day 2, 95, day 4, 90, and day 6, 85. So that's what the water measured. And that does kind of coincide over here with the shapes of these containers, because this container is the widest. This one will be the second widest, the third, and the fourth, and that shows our results there as well. So the question is asking us, in which container will all of the water evaporate first? Well, let's take a look at where we are over here at day 6. Which one is already closest to 0? Exactly, the cake pan. So the cake pan is going to evaporate first. Okay, it has a lot to do with the shape and the amount of exposure of that surface area to the air. Okay, cake pan is definitely going to evaporate first. And if the conditions stay the same, on which day will all of the water evaporate from this container? Well, it's going down in a pattern here. Went from 75 to 50 and from 50 to 25. So what's the pattern? Minus 25. So if it's minus 25 and then minus 25, then if we take 25 away and we're going every other day in terms of our measurements, then by day 8, it should be 0. Okay, so again, it asks us to show our work on the next page. We can simply just write it here. 75 minus 25 is 50, minus 25 is 25, minus 25 is 0. Okay, so obviously, which day? Day 8. All right, now let's take a look at the other questions below that. Okay, in which container will all of the water evaporate last? Well, let's take a look at our results again. Which one is the furthest one away from 0? Exactly, the olive jar. And what did we say about the olive jar? We said that the olive jar was the skinniest of the containers, which means it's going to evaporate, take the longest to evaporate. Okay, so which container will all of it evaporate last? It is going to be the olive jar. Okay, and our question is, if conditions stay the same, on which day will all of the water evaporate from this container? Show your math on the back of this page. So in this case, what's happening is it's only going down by 5. So it's going from 95 to 90 to 85. So on day 8, if we were to continue it, day 8 for the olive jar is going to be 80. Day 10, 75. Day 12, 70. Day 14, 65. And we got to continue this pattern here. Okay, if we continue this pattern, eventually we're going to get down to the very last not being 0, but how many more times do we have to do that? And we're going down by 5. So day 15 is going to be 60. Day 16 is going to be 60. So you can continue that pattern down here at the bottom, right? Day 16 is going to be 60. Day 18 is going to be 55. Day 20 is going to be 50. And guess what, friends? You might be able to use this to sort of figure out how many more days it's going to take to get to 0. And if you said by day 40, which would be double this, you're exactly correct. Okay, so by day 40, it will be at 0. Nothing left. 40 days. Okay, so your answer is 40. And again, you can go through the whole process. You can keep going down. Day 22, 45. Day 24, 40. Day 26, 35. Day 24, 30. You can keep going if you want, but I'm telling you, if you simply double this, okay, you would get your day 40 at 0. All right? And so that is it for that particular lesson for our math extension. And again, that coincides with the experiment that you did on the evaporation surface areas, how the surface area affects the rate of evaporation. All right, I will see you in, let me put this up here. I will see you in the next lesson. Bye-bye.